Alright, good morning class.
Good morning, sir.
At this point we're busy with 3 graphs. Was there anything else I needed to mark in this lesson? We finished 7 point something, 7.10. So from 7.10 we went into 3 graphs before we go into general solution. So I'm just going to finish this section of work, this chapter, and then we're going to go into functions. So the last part of the general solution we do after the June exam. Okay, or a couple of days in the June exam, I'll tell you. No, that's not fair, no? No. I was going to say, why don't we have a couple of classes in the afternoon after you write your paper that day, like in the June exam? So I thought to myself, no, that is not fine, not fair. No? Maybe you have to study for LO the next day and so on. Yeah, definitely. Yeah. So, yeah. So we would rather do it on a Saturday. Yeah.
Not Saturday.
Okay, listen. Everybody's going to have their own excuse, okay? And you got extra maths. Nice. Keep it that way. Right, people. So at this point in our lives, we did exercise 6.1. Have we completed it? No. What about number 3? We did that as well. B, 3B, or not to be. No? Shakespeare. Since you guys are dressed up like Shakespearean characters. Yes. Yeah, that's what I also remember. That's the one thing I remember. To be or not to be, what came after that, I don't know. Huh? Okay. Now I also know. Yeah. But anyway, here we go. The question is in 6.1, number 3B. Well, you have to determine the equation of the, where you must calculate the A value, no? So the graph is going down here. Not so. So that A value, of course, is going to be negative. The maximum value, which is half minus half, divided by 2, which gives you half. Not so? And yesterday we discussed why or how what the importance of this formula is. Okay. Then we went on and we said, okay, number 4. Yeah, this is where I wanted to be. So the question says, a little bit smaller, OCD here. Part of the following curve represents a graph of y is equal to cos theta, where theta is an element of negative 360 to 360. That means to say the graph is drawn in that interval. Okay, you guys understand? Right. Through which point will the y-axis pass? So if this is negative 360 here, and that is 360. How do I know that? Because of that. Where would the y-axis lie? Huh? Through I. Why? Because the graph, the cos graph starts on top. Not so. It's maximum. We put it through I there. We want to make it solid. We should solids rather than stripes. No? You guys know? You guys play pool? Snooker? Pool?
No.
No. Shame. I think when you shoot the ball with a cue and you don't play those things. The cue is. No, you get a pool with the balls, no? You know pool?
Yeah.
Now a different form of the game is snooker. Snooker, yeah. It's a different form. That is, it's basically a bigger table, and with that for those of you who played the game pool already, you first shoot the solid balls or the stripe balls, no? Either or. You're one of the two categories. Whereas in snooker, the other game, you first have to shoot the red body, and then you call your color and you shoot the color body. But this works with points now. A red ball is 1 point, and a black ball is 7 points, and a pink ball is 4 points, and yellow ball I think is 3 points. And that game is based on points. Whereas in pool, if you shoot the last ball in, your last ball, then you win. This year, you win on points at the end of the day. Don't win on whoever shoots the last one. Okay, so it's two different games. But anyway. Right, so you say it must go through I. So that is correct. Next question. Write down the coordinates of the points D. So where's D? Yes, so that is going to be 90 and 0. Not so. H is going to be negative 180 and negative 1. How do I know that? Because the amplitude is 1 there. Not so. It's 1 and minus 1. Alright? At which point will theta be negative 360? So that is point A. And 360 is point F. How many units will JL represent? JL? Yes? Okay. No, you're absolutely correct. So then, yeah, you're absolutely correct. Because here part of the following curve represents. Okay, I didn't read properly. English is important for some of us. Alright? Part of the following curve is represented of y. So it's actually more than the graph itself. So if you're looking at the cos graph, it starts there and ends there. So that's actually a 360. The graph is going from there to there. So yes, this is not good. So it's actually through G and K. There we go. So how many units will JL represent?
1.
JL is 1. Okay. Okay. Then we went on to changing period. But we homework, you had to read through this, do this investigation here. This was on page exercise 6.2. Page 189. Nobody's confused yet, no? Let me know when you get confused. So we're looking at change in period. So investigate the graphs of the following. So you have to develop a table in the intervals of 45. But that I showed you how to do, no? You're going to use a calculator here. So it's going to be through the corresponding graphs and each. Okay, so it's going to pull up the axis. Okay, so I know these three graphs, so later on you must just give me the values, okay. Alright, so they ask you to develop the tables. So here's draw the corresponding graphs, each on the same system of axes as the graph of y is equal to sine x. So let's go with A. So if you're looking at the y is equal to sine x graph, the graph starts here. 90 is 1, 180 is 0, 270 is minus 1, 360. Then minus 1, 0, 1. Not so. So this is the sine of x graph. The board is for some reason not aligned. Alright, so that is the y is equal to sine x graph. So what was the graph in A? What was the first graph you had to draw? Y is equal to sine 2x. So I showed you yesterday how you can plug this into a calculator. So you press mode, you're going for table, sine 2x, your alpha. Close the bracket. We don't have another graph that we're interested in. We're going to start at negative 360 to 360. You're going to go with steps of 45. So 360 gives you 0. Not so? The negative 315 is negative 1. 270 is 0. And so on. You all got that, no? Okay. So we do what we do best again, connect the dots. There we go. And this is the y is equal to the sine sine 2x. Not so? So what do you see? What is different here? What's the amplitude of that graph? Still 1. Why? Because the measurement from the maximum to the neutral point is 1. So the amplitude is still 1. But what else do you notice? What is the period of the original, the graph in the red? The period. What is period? This is time taken to complete one full cycle. That's your period. No? So the red graph's period is what? 360. Starting from 0, maximum, minimum, back to 0. So that distance it covers is 360 degrees. Not so? So the period of that graph is 360, which means to say every 360 degrees a new cycle will be created or formed. Not so? So what do you notice with regards to the period of the graph in blue? It's 180. Can you see that? So there, from start to end, it's 180 degrees. Okay? So how does that affect what I have on what I'm familiar with at this point? Is that the period of the original sine graph is 360. So the period of this graph, of the sine graph, would be 360 divided by the b value. Where does b come from? If it's in the form of y is equal to sine bx. If the formula is in that form, then the period of the graph for sine and cos will be 300 divided by that b value. So make a note there. For sine and cos, sine and cos graphs. I'll need you to make this note, okay? The period will be affected as follows. The period is equal to 360 divided by your p value. Okay, so what's the period of this graph? 360 divided by that 2 there, which is 180. Does it make sense? So before I take it off here, I just need to see what else I want to explain. The effect that the variable b has on the graph. You may find it useful that the table mode on your calculator you could also. Okay, that is what we just came up with. Here you can download this autograph. But it's not essential, it's not necessary. Okay? But if you that kind of girl that wants to play around with the apps and work, it's a nice app to download. Desmos on your laptop, computer or phone. If you punch in sine of x, it will draw the sine graph. Later on, when you got the parameters and those graphs, we're going to still be drawing this term. You just punch it in there, and you see. Then you can actually mark your work from there, and you can see you're on the right track or what. Okay. Okay, so you guys got this. So that is for the sine and cos graph. What do you think? What difference would it be for the tan graph within your period of the tan graph? Here we go. The tan graph, well, the period would be 180 divided by that b value, if it's in the form of tan of bx. Okay. You all okay with that? Alright, so let's take this off. Let's give the graph in the reader on. Why are we keeping that graph? Because as I said, that you must draw the graphs. You must first draw the y is equal to sine x, and then you draw the other graph. That's what it's a question. Okay. So let's go with the next one. B. What's the question B? Y is equal to? Sine of half x. And I told you the steps here is going to be, instead of 90, it's going to be 90 divided by half. And what is 90 divided by half? 180. No? What's 90 divided by 2? 45. So how can 90 divided by half also be 45? So 180. No? But what will the period of this graph, without drawing this graph now, what's the period of this graph? It's going to be 360 divided by half. And 360 divided by half is what? 720. So it will take 720 degrees to complete one full cycle of y is equal to half x. Does it make sense? So let's go. We're going to plug this in the calculator again. So we go, we press AC. It will take you to the original. We press AC twice. It will clear what you have worked out in. So and it keeps the other parameters. Okay. So you will have sine of a half x. So 1 over 2 x. Close the bracket. Equal. No g. Start negative 360 to 360. Now say you carried on with steps of 45. And you didn't know you had to divide 90 by half and all. Then these are the values you're going to get. So negative 360 is 0. Not so. Then, you see 315 is an irrational number. Negative 270 irrational. 2 to 5 is irrational. Negative 180 is negative 1. So what I do is I gather all the rational values. Makes it easier to work with. Okay? So the next point of importance is negative 180, so it's minus 1. 0 would have given you 0. 180 would have given you 1, and 360 gives you 0. And there's your sine graph. Okay. Importantly, I draw in negative 180 and negative 1. I had to do it on the previous graph as well. I forgot. 180 and 1. Here is 90 and 1. 270 and minus 1. That is negative 270 and 1. Negative 90 and negative 1. Okay. And since there's more than one graph on the system of axes, I must name the graph as well. Not so? So y is equal to sine of x. Alright. Well, again, what do you notice here? Your period is 720. Although the graph is cut off at negative 360 to 360, this graph actually carries on. No? This is the graph carries on to infinity in both directions. Positive infinity and to negative infinity. Okay, any confusion here? What's that? Was there an amplitude change in this graph? No. Still from maximum to the neutral point or 0 or the middle point, it's still a distance of 1. The amplitude is still 1. And we know we read the amplitude basically off from the number in front of the x, in front of the ratio anyway. Okay. So that's that. And see, it was y is equal to sine 3x, no? So what's the period of this graph? It's going to be 360 divided by 3, which is 120. So that means you say the graph completes itself in 120 degrees. Not so. So it will go to 120. So this what's name not going to be of much of a benefit to us. But we know that the steps, the in-between steps should be 30 degrees. No? How do I know that? It's going to be 90 divided by 3. So say again you didn't know that. We know the period is going to be 120. And there's 4 critical points in this graph, or 5. No? There's 1, 2, 3, 4, 5. Okay, so normally what we say is 360 divided by 4. So that's 0, 0. It then gives you 90. But if that is 120 divided by 4 is 30 degrees. That's another way of knowing what should your increments be. Okay. So it's going to be sine 3x. No g. Yes, that's correct. Steps of 30. Okay. Insufficient memory. So that means you say there's too many points that the calculator needs to work out and display. Okay? So what we do is we reduce. Let's say we start at negative 360 to 0. You end at 0. So that's not cutting that information in half, or those points in half. Can you see that, people? So negative 360 is 0. The next value, so here we must go in increments of 30. So it's 30, 60, 90. Negative 120, negative 150, or negative 180. Negative 210, negative 240, negative 270. Negative 300, negative 330, and so on. You see what I'm doing? Alright. So 0 gives you 0. Negative 330 gives you negative 1. 0, 1. You know? Right, I think I'm going wrong here. There's 1, 2, 270 is wrong. 270 must be here. There. Up. There we go. Nope, again a mistake. Can someone just give me the values? Otherwise I must pull out the calculator every time. Negative 330 gives you 0. Negative 330 gives you negative 1. Is that correct? Sorry? Is it 1? Negative 330 is 1. 300 is 0. 270, negative 1. 240, 0. The next one is 210, is 1. The next one, 0. Then, negative 1, 0. 1, 0. Negative 1. There we go. So again we connect the dots. Oops. Okay. And on the other side of this graph, you're going to get the same thing. Okay, let's just pull this out here. On that side you're going to get the same. Okay, this is actually come over. Okay, and you see it completes 3 cycles in 360. You guys understand? So that is just what they wanted you to show them. What I want to do is I'm going to draw this graph quickly for you on the graphing program, You guys can do the others. I'm just going to do one for you to show you how it looks. Remember that the sine, cos, tan, all these graphs are smooth curves. No? You don't draw this with a ruler. It is freehand drawing there. And it's a smooth graph or curve. Alright. Let me just get this program up here. Prepare our axis. It's from negative 365. So that you can see the 360 and 365. Show ticks. You're going to show a grid. You're going on units of 30. Steps of 30. 30. Your y-axis, let's go with minus 2 and 2. Show the grid there. You want 1. Right. Then the function, let's insert the sine graph. Oops, function insert. We're going to draw the sine graph, okay? Sine x, I don't think I changed my degrees, I'll change it now. From radians to degrees. So it's negative 360. We're drawing the graph from negative 360 to 360. Okay. Let's make this color. Okay. But of course that is not right, because the calculator, the program is in radians. We are working at high school in degrees. So for those of you going to go to university, you study maths at university, all your calculation is in trig is going to be done in radians. Okay. So copy. So this is what you should see there. Okay. So you see there, people, the curve. The nice smooth curve for the sine. This is a sine x graph. So on this graph, I'm going to add the sine 3x graph. So insert sine 3x. Let's make that blue. Okay. Or navy, whatever. Navy is fine. Almost black. Okay, can you see there the graph is going past this 360 here? So I had to restrict that graph there. So go back there, you want to draw it from negative 360 to 360. And there we go. Can you see the graph is now within that given domain there? Remember, if you're going to draw the graph, if the question says draw from negative 360 to 360, and you draw over that given domain, of course you're going to lose the mark. Okay, yes, Michael? If they don't give it, then you can do anything. Then you draw it from 0 to 360 or from negative 3, then it doesn't matter. But the rest is sure in the exam, they're going to give it to you in a given domain. Otherwise, everybody's going to come with their own values out. You understand? So we think of that already. Okay. And if the examiner forgets to write it in, don't worry, you do your own thing. You must get the mark for it. Yes.
Let's say they don't give us the domain, and then I goes from 0 to 180.
You should get full mark. Yeah. Listen, at the end of the day, the learner gets the benefit of the doubt always. Okay, because if we didn't say, then you must be awarded the mark for doing the sum. You see, that's why maths is so easy, man. Yeah. No? Alright, but here's that graph. Can you see, from start to end, the graph completes itself in 120 degrees. Can you see that, people? And then there's your second cycle and your third cycle and so on. Alright. So that's exercise 6.2 for you. No? So we did change in period. 6.3. They ask you here in 6.3, write down the period of each graph. So you can do 6.3 number 1 and number 2. That's your homework, no? Which page is this on? Hello? Speaking? Okay, so your homework is just refreshing what we have just done here. So it's exercise 6.3. Okay. Then, sketching graphs with a change in period. So let's do these examples quickly. And then part of your homework is going to be exercise 6.4. Okay, so you got 2 exercises for homework, 6.3 and 6.4. Okay. So there's about 5 minutes left of this lesson, so I just need to wrap up this thing quickly. So draw the graphs. What do you notice here? No period is given. Okay. So I'm going to just draw it from negative 360 to 360. Okay. So all the explanations is done from this textbook within that given period there. Okay. So is that okay? I don't have to draw it from 0 to 90 and expect full marks and all of those things now. No? So we're looking at sketching graphs. No? You want me to put the heading there? Whoops. What? Okay. So the first graph we're looking at, let's just get you a reading there. Okay, people, what page are we on? Page, yes? Page 199. 193. Okay. Alright, so sketching graphs with a change in period. This we went through already. The period of the graph of a function in the form y is equal to bx, y is equal to cos bx, and y is equal to tan bx can undergo changes in period. The period y is equal to sin x, y is equal to cos x is 360 degrees. Thus the period of y is equal to sin bx and y is equal to cos bx is 360 divided by b. So the basic cos graph and sine graph completes itself in 360, and that we use as our guide. Alright. Then the period of the sine of the y is equal to tan x is 180, thus the period of y is equal to tan x is equal to 180 divided by, that we already made a note of, no? Consider the graph y is equal to sine 2x, the period is going to be 360 divided by 2. Right, we pass on that stage in our relationship already, no? Alright, let's carry on. Alright, so let's do number 1. Number 1 says, draw the graph y is equal to cos a half x. People, what's the amplitude on this graph? 1. So it's going to be between negative 1 and 1, the range. No? Then we are told you got cos of a half x. So the thing I'm interested in is my period. So the period is going to be 360 divided by a half, which is 720. Now if you look at the basic cos graph, and this is what I do. No? I don't use a calculator all the time. So I go the cos That's the basic cost graph. That is 1 and minus 1. Then I do the changes on the side here. If you're going to go, if this is 360, then this point here is going to be now 720. Not so. So if that is 720, that is normally 180 is now going to be 360. Can you see that? So it's only that part of the graph that I'm going to be able to draw. So you go 0. Whoops. 0. This is normally 90, but it's going to be now at 180. This is normally 180 is now going to be at 360. Can you see that? So that's, whoops. Board is acting up again. That time of the, not month, the day. The board acts up like this. No? Everyone's tired already. So it's 360 and minus 1. Do you guys understand? So of course the graph is coming this side as well. And the graph is symmetrical. So that is what the graph is going to be. And no stress, no fuss. There's the graph. Alright.